Hi guys, today's video is going to be about drawing polyatomic ions. Okay, now I really suggest that you should have had a look at a couple of videos before coming to this one. So if you haven't had a look at the one I've got about how to draw molecules, and you haven't had a look at the one about coordinate covalent bonds or expanded octets, you really should look at those as well, because this kind of all brings it together in this video for the last bit about drawing molecules. So instead of drawing just a molecule, what we're going to be looking at is something with a charge. So the key point of this is that a single lone electron, which is represented by a dot, and we show when we draw the electron dot structures, has a negative charge. So if we have a negative charge on an ion, such as a 2-, that means we need to have two individual lone dots somewhere in there. So I'm going to start off by showing you this one, carbonate, CO3 2-. So the carbonate ion has a central carbon atom, which has 4 electrons on it, like this. Okay, and then we've got 3 oxygens which are evenly spaced around it. So I'm going to just evenly space the oxygens around it here. Each of those oxygens has 6 electrons on it. Okay, so you draw this up as you would a normal molecule when you're trying to draw that. But before you start bonding things together, you need to take into account the fact that this has a 2 negative charge. Now, a 2 negative charge is going to equal 2 individual lone dots that we want. Okay, now those lone electrons need to be on different atoms. Okay, so what we're going to do is we're going to choose a lone electron here. So I'm going to choose this one off of this oxygen, and I'm going to choose this one here off of this oxygen. So that's going to give us a negative charge, and that's going to give us a negative charge. So what I always suggest, and I'll show you another one after this that's got a different charge on it, but what I suggest you do is you just find a lone electron, you make that one your negatives, and then you go to the next atom and you keep adding it in until you equal up to your charge that you've got. Then what you do is you start bonding everything up like you would normally. So this oxygen is going to need a bond over here. Remember, we're keeping that one free. This oxygen is going to need a bond here. This oxygen doesn't want to have a charge on it, so it wants to have both those lone electrons bonded up. So what we've now done is we've got a carbon with a double bond to an oxygen, and then we've got 2 lone oxygens over here with a lone electron on them. Okay? There's no lone pairs of electrons around that carbon, and so the shape of this molecule is going to work out to be trigonal planar. So we're going to have a carbon in the middle, double bonded to oxygen at the top, single bonded to oxygen over here. Now you don't need to show those lone electrons there for the charge, but what you do need to show is that this structure does have a charge. So to do that, we put square brackets around the molecule, or the ion I should say in this case, and we indicate the charge up here. So this is a 2-. So the key thing that you need to do with ions, alright, is to make sure you put the square brackets around it, right, and you indicate the charge at the top here. So CO3 2-, we've just transferred that charge over. We're showing that this is the shape, the trigonal planar shape of our carbonate ion. 2 single oxygens here both have a single electron on them there, a lone electron, which gives us our negative charge. Right, I'm going to show you another negative one and then one positive one, because it's always good to end with a positive. So the negative that I'm going to show you, the next one, is I'm going to go to one of the sulfates. Alright, so I'm going to show you the sulfate ion, SO4 2-, because again this is really good. It shows us how we can have an atom that has an expanded octet, and I referred to an expanded octet as one of the other videos I've done that I recommend you have a look at. So the sulfate ion is SO4 2-. So when you draw this up, central sulfur atom with 6 electrons around it like this. Okay, and then you've got 4 oxygens evenly spaced around it like this. Each of those oxygens has 6 electrons around it as well. And I'm hoping that these electron dots show up clearly for you in the video. Like this. So we're just doing it like we would normally. If you've watched the video on expanded octets, you'll know that sulfur in period 3 can expand its octet and have more. But what we're focusing on in this one is the fact that we've got a 2- charge. So once again, we want to identify 2 electrons that we're going to keep free and not bond up. So I'm going to choose this one here, I'm going to keep that one free, and I'm going to choose this one here, I'm going to keep that one free. Doesn't matter which ones you choose, as long as they're on different atoms, Alright, and we need to have the same number of free electrons here we've got as we do up here. Alright, so these two electrons are not going to be involved in bonding. The rest of them though, we're going to bond up. Okay, so it doesn't really matter how we do this. Alright, we just need to kind of bond them up. So this is going to bond like this, that one's going to go over there, and that one's going to go there. Alright, so we've got an expanded octet for our sulfur. Okay, which is not really the point of this video, but I just want to remind you again that it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 electrons around it, which is okay because it's in period 3. And then we've got all our oxygen. These two have both got 8 electrons, they've got full outer shells, they're fine. These ones have only got 7 electrons around them, which is okay. That's why we have these lone electrons to give us a negative charge. So to draw up this structure, no lone pairs around our sulfur. So we've got 4 atoms evenly spaced. We're going to end up with a tetrahedral arrangement around our central sulfur. Doesn't really matter whether this oxygen is here, here, or here, the double bonded one. It's still the same molecule when you rotate it in 3 dimensions. But what is important is that we've got 2 single bonded oxygens, and because it's charged, we want to put our square brackets in, and we want to have our 2 minus charge there. So there's the tetrahedral arrangement for our sulfate ion, with the 2 single bonded oxygens that both have a single lone electron on it, which gives us our negative charge. Now I talked about how I was going to finish with a positive one, because the positive one is kind of the same process, but obviously this rule here doesn't quite apply. Basically what it wants though is when you have something that's a positive, all right, instead of having 1 lone electron, you want to make sure that you don't have that electron in there. So I'll show you what I mean by that. Alright, so this is going to bring in again the coordinate covalent bond theory, which is something that hopefully you've had a look at with the video, because the positive one I'm going to show you is the ammonium ion, NH4+. Okay, so it's a nitrogen with 4 hydrogens and 1 positive charge on it. So if we draw up this molecule, okay, or this ion I should say, we've got a nitrogen in the middle, which has 5 electrons around it, and then we've got 4 hydrogens which we're going to evenly space all the way around. Okay, so this is what we're aiming for. Each of these hydrogens has 1 electron on it like this. Okay, now nitrogen is only in period 2, so it can't expand its octet. What we're going to do is we're going to bond these up here like this. And that's what you would have for a normal ammonia molecule, NH3. A nitrogen, lone pair of electrons up the top, 3 hydrogens around it. If you bond up from this electron to here, what you're going to do is you're going to give nitrogen 9 electrons, which is too many. But we want to have a positive charge here. Now, for a positive charge to occur, we need to have lost an electron. So what actually happens in this situation is that this hydrogen, we actually lose an electron. So if you have a positive charge, you actually want to delete out an electron somewhere. And what happens is that this lone pair of electrons here actually forms a coordinate covalent bond towards that hydrogen. Okay, so you've still got the 2 electrons forming a bond, but now we haven't expanded the octet for nitrogen, which is really good because we can't go beyond 8. And so now what we've got is a tetrahedral arrangement around the central nitrogen. So this positive ion looks like this. We've got a hydrogen at the top, that's a coordinate covalent bond there. We've got our other hydrogens around like this in a tetrahedral arrangement, and because it's an ion, we put our square brackets in, and it's this time got a positive charge. And it's got that positive charge because we've lost an electron up here. So if it's a negative charge one, like the first I've shown, you want to make sure you've got a free electron dot somewhere. If it's a positive charge like this one, you actually want to remove one of the electron dots somewhere. So in this case, I removed the one from the hydrogen. We formed a coordinate covalent bond up there, and we've now got a positively charged ammonium ion. Alright, hopefully, like I said, if you've watched these other videos, hopefully this has all come together and been pretty straightforward. If you've got any questions, just ask though. If you've got any suggestions for any other videos you'd like me to do, please put those in the comments below as well. Alright, as always, have fun, enjoy chemistry, and I'll see you in the next video. Thanks guys.